Morning guys. Last week we went over some perimeter and circumference of circles. So what I'm going to do today is I'm just going to do an introduction to area. So if I had, just to recap, if I had a square, so that's all sides are the same and these are at right angles, and that square had a side length of 4 centimeters, then our perimeter, well, that was the length, total length around the outside. So that was 4 plus 4 plus 4 plus 4, or 4 lots of 4, which was 16 centimeters. So that was 16 centimeters around the outside. And so what we're going to look at today is not the length around the outside, but this area in here. So if I took a rectangle, let's say it is 5 centimeters by 7 centimeters. It's a rectangle, so that length and that length are the same size, and that length and that length is the same size. So I'll mark those slightly differently. We could easily calculate the perimeter of that, right? It would be 5 plus 7 plus 5 plus 7. And what's that? That would be 24 centimeters around the outside. Perimeter is 5 plus 7 plus 5 plus 7. And that's going to be 10 and 14, 24 centimeters. All right, so that's like one-dimensional, right? That's just a length. What we're going to calculate now is area. So you can think of area, you can think of a square, a 1 by 1 square. Well, we would define that as, if this was in centimeters as well, a 1 centimeter square. So it's just 1 by 1. That's our most standard unit of area, is a 1 by 1 square. And what we're going to ask is how many 1 by 1 squares can we get into this thing? And so we're going to start with just counting. So if I can get 7 of them along the base of this, I'm going to get 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7 along this base. Okay. Not drawn particularly well, they don't really look like squares, but I think you can get the point. So if we get 7 along the base, we can get 5 up along this side. So there's 1, 2, 3, 1, 2, 3, 4, 5. Again, not drawn on scale. And then we could count up all these 1 by 1 squares. So 1, 2, and that's going to take us a wee while, but what you hopefully you recognise is that to calculate a number in here, it's really just a simple multiplication of 7 times 35. So area is in fact 5 times 7, which is 35. And then we answer with units. They are square centimeters. So length is just centimeters, area is centimeters squared. Great. So why don't you give this one a go? Let's say that this is a 9 by 4 meter rectangle. What is the area? Hope you realize that that's 4 times 9, which is 36, I believe. And in our units are meters squared. So area of a rectangle, well, that's just going to be what we call the base and the height. So we just multiply the base by that height. It's our most standard way of measuring area. So that's why I've started with it. So base times height. So the area is BH for a rectangle. Base times height. And there's your first record of learning for today's lesson. If we have a rectangle that has a base of B and a height of H, then its area is just base times height. And I'm sure some of us would already have realized that. Okay. The next thing we're going to do, that's paper from last time. The next thing we're going to do is a parallelogram. I want the area of a parallelogram. Parallelogram. Okay, so if you didn't know what a parallelogram is, it's where these two sides are parallel and the same length, and that means from some geometry that also means that these two are parallel and the same length. And so I want to know, how do I calculate the area of that? So if the rectangle, it was base times height. So, and notice this isn't really the height anymore, it's skewed across. So let's just go base times, I don't know, the length of this. Do you think it's going to be b times l? Because that would be the most standard way of coming into this problem, right? You've just seen the rectangle. It might be this length here times this length here, just like the rectangle. But let's have a look at what happens if we make this skew more and more. What's actually happening to the area? So let's keep these lengths the same, but let's skew it across more and more. So I'll try my best. So I've got this length here, and let's skew it across even more. All right, and then let's do it again. What's happening to the area as it's flattening out? Because it's going to end up being, it's going to end up being a flat line, isn't it? The area is getting less and less as I tilt it over. But with keeping, hopefully you can see I'm trying to keep this length and this length to be pretty much the same, right? So we can't multiply those together. So what we do, so I've got this this parallelogram here. All right, let's define, let's manipulate this a little bit. So let's say that this is the base, but let's define a different line. Let's go perpendicular to this baseline here. Let's call that h, because that is its height. So I'll keep that heading up here. Area of a parallelogram. Spelling is pretty average sometimes, so just checking that. So we've defined height now. Now let's see what happens if I just get my scissors and I cut down that height line. Alright, so I've just cut that down. Let's now take this triangle, and let's put it here. What have I now created? Well, it's a rectangle, isn't it? And that is still the same base, because I've just got that line there, I've just shifted across. So the area of a parallelogram, I remember parallel, two parallel lines are in parallelogram. Well, it's base times height. It's just like the rectangle, except that the height is defined, let's just put this back, height is defined as the line that is perpendicular from the base up into that corner. So that is your height. Sometimes your height might be defined on the outside, such as that. So with that, why don't you try calculate the area of this parallelogram where its height is, let's say, 10 millimeters. I think it might almost be 10 millimeters. Oh, close. And let's take a width of 25 millimeters. Then the area is simply 10 times, because we've got the height, 25, and that's 250 millimeters, and we have them squared because it's area. We get 250 1 millimeter by 1 millimeter squares in there. Okay, cool. So that might be a nice wee record of learning for you as well. I'll just leave that there for a second. Right, you might want to just draw in a parallelogram like this and put a dotted line for H, get your formula, and there's a wee example. There's a wee example of calculating the area of a parallelogram. The last one I'm going to do today is the triangle. So if we're calculating the area of a triangle, okay, let's take this triangle. If I want to calculate the area of that thing, well, I'm going to need to do a little bit more manipulation like I did with the parallelogram. So I'm going to do the same thing I did with the parallelogram. I'm going to define height as the perpendicular line straight through, and then we're going to define this length here as the base. So what do we think? Is it going to be base times height? Well, to get the formula, I'm going to do something a little bit sneaky. I'm going to copy and paste. So I've got two of them now. I'm going to calculate the total area. I still can't do that. So what I'm going to do is I'm going to go and I'm going to flip this triangle around and just put it on there. What do you notice I've just created? Hopefully you can see that I've created a parallelogram. And we just said that the area of this thing, this area, is equal to base times height. Base times height. If this is a parallelogram, okay, by flipping that triangle, I can always make a parallelogram, I believe. But we didn't want the total area, we only wanted half of that area. And so I just put a half. So the area of a triangle is half base times height. And now it doesn't matter what order you do that in because it's multiplication. So let's have a look at an example. Let's get this triangle and let's give it a height of, say, 6 centimeters, and let's give it a base of 10 centimeters. So we could go area is a half times 6 times 10. Doesn't matter the order because multiplication. Half times base times height, half times height times base, whatever. So we could half to 6 and call that 3, and then times that by 10 and call that 30, and that's centimeters squared. We could have done 6 times 10, which is 60, and then halved it and got 30 as well. We could have halved the 10 and got 5, and 5 times 6 is 30. So it really doesn't matter too much. But that is our last formula for today before we go into another one, which we'll be doing next lesson, which would be the trapezium, where these lines are parallel. So we'll be doing that next. But before you go, here is 6 problems for area. Notice that I've got 2 compound shapes. So you can pause the video there and give those a crack. Right. Notice that this is a square, so this should have right angles in it. But it's a 4 by 4 square. So that means that this must also be 4. And notice that with these squares and rectangles, it's simply just area is base times height. So 4 times 4 is 16 units is meters squared. And that's why 16 is a square number, because it's a number that you get by multiplying the same number, right? So it's got a width, a base and a height that are the same. So that's why 16 is a square number. And that's why 4 is a square of 16. So that all comes out. So if you're doing this one, the area is 8 times 11, which is 88. And so your area should be 88 centimeters squared. A triangle, right, when it's a right angle, you could do this and then half it. So a right angle, its height is actually this length. So I probably should have stated that in that last problem, but when it's a right angle, that is its actual height. So it's its area is a half base times height. So that's going to be 20 meters squared. A half of 40, or a 5 times 4, or 2 times 10. Alright, the parallelogram, its area was base times height, and we've been given its height here, its vertical height, and so that's just going to be 5 times 3, 15 centimeters squared. Okay, now we have a compound shape. So I'm going to slice the roof off of this little pentagonal house. I'm going to calculate this area, so area 1, and then I'll calculate area 2. So area 1, that's a square, it's a 4 by 4, just like up here. So it's 4 times 4, which equals 16 meters squared. And area 2 is a triangle, so it's half the base and times by height. So that's going to be 6 meters squared. So area is going to be 22 meters squared. Hopefully I've done that right. Now there's a couple of different ways you could go about splitting this. I'm just going to split this down here. So this rectangle, let's go A1. Area 1 is just a 3 by 10 rectangle, which is a 30 centimeter square rectangle. And so I want to calculate the area of this thing. It's no longer a base of 8 because I've already calculated all of this. It's now got a base of 8 minus 3. So this is a 5 centimeter by 4 centimeter. So A2 is 5 by 4, which is 20 centimeters squared. And so our total area is 50 centimeters squared. Awesome. I hope you got all of those correct after those definitions. If not, just go back and try those again, see where you went wrong. Awesome.